Hey everyone, and welcome to Chemistry by Sir Usman. In today's video, we are going to be beginning with the second chapter of O-Levels and IGCSE Chemistry, which is the atomic structure. Bear in mind that these chapter numbering, they are according to the way I teach, and they might not correlate with the original actual the exam syllabus that is provided by the IGCSE and O-Levels Chemistry syllabus content. Okay, but majority of it is similar. Okay, so in the way I teach, this is the second chapter, the atomic structure. And in the atomic structure, what do we study about? We study about how an atom is arranged, what is the structure of a single atom. So we're talking about single atoms over here. Okay, so atomic structure, it is the arrangement of atoms and its subatomic particles. Now what are subatomic particles? For us, there are three subatomic particles. Even in A levels as well, there are only three subatomic particles that we have to worry about. Are there other subatomic particles? Yes, there are other subatomic particles, but their existence is very limited, and we don't really talk about them much because they don't contribute as much as these three subatomic particles. And what are they? The names are proton, neutron, and electron. All right, we should be able to know their names, and then we should also be able to know where they are located. So the proton and neutron are both located in the center of an atom. That center is called the nucleus. And electrons, they are found rotating or revolving around the nucleus. That is called the electron shell, or it is called the orbit, or it's called the energy level as well. All right, so the word energy level is also used for the shell of an electron. Okay, now if we talk about their relative charges, bear in mind these are relative, meaning compared to one another. These are not their actual charges, because the actual charge of subatomic particles is extremely small, because subatomic particles, they are extremely small. So the relative charge of proton is +1. In reality, the relative charge of proton is 1.6 times 10 to the power minus 19 coulombs, right? Positive 1.6 times 10 to the power minus 19 coulombs is a very small value. Coulombs is the unit of charge. You might study that in physics. So this is the charge, the actual charge of proton, but this is so small that it is incomprehensible or difficult to use in calculations or use in understanding in many places. So therefore, we just consider them to have their relative charges, like +1. Neutron is completely neutral, it has no charge, and electrons has -1, meaning electron and proton have the same charge on them. It's just opposite in sign. So proton is +1, electron is -1. In reality, electron also has a charge of -1.6 times 10 to the power minus 19 coulombs. Okay, but that again is very small charge. For chemistry, we don't really have to use the actual SI units. Therefore, we can just call them +1 and -1. Similarly, their relative mass, once again, the mass of proton and electron is extremely small. So therefore, their actual mass in kilograms is not used. Instead, a unit for the masses of subatomic particles is devised. It's called the atomic mass unit, AMU. All right, atomic mass unit would mean the unit which measures masses at atomic level. So protons, they have an atomic mass of 1, and neutrons, they have an atomic mass of 1 as well, and electrons, they have a mass of 1 upon 1840 atomic mass units, which for our syllabus and for A levels as well is considered 0. Okay, so atomic mass of electron is or the relative mass of electron is considered 0. Why? Because if you compare this value, what does this value mean? If you compare the mass of electron and proton with one another, let's say you have a beam balance. A beam balance is a balance which balances or measures the weight according to or relative to another thing. So if you have one proton on this beam balance on one side, then that proton will be balanced by 1840 electrons approximately. So that means 1840 electrons are as heavy as a single proton. Is that of any relevance? No. So basically, this would mean that if you have a bag containing some heavy fruits like orange and apple and mango, for example, and you have like 3 kilograms of apples in a bag and 2 kilograms of oranges in a bag, and then you decided to put just a single grape. So a single grape, you just put it in that bag. Does that really affect the mass of the bag in the grand scheme of things? No, it does not. You won't even feel a difference, right? Because the mass is so small. Similarly, having electrons or not having electrons also does not really contribute much to the mass, because the largest element that we know of also only has about 118 electrons. Okay, so the elements that we know of, their electrons are not as many even to make up one atomic mass unit. Therefore their masses are just considered to be neglected, right? Their masses are considered zero, therefore. Okay, so that is the basic understanding. Very few times has it arrived as it is in the table that you can see in the on the screen, to write down the empty places, right? So for example, they might not have this place, they might not have this place, they might not have this place, and then you would have to fill this table and get marks for it. But that happens few times, but you should know of them. Okay, anyways, now let's, if you look at the general two-dimensional diagrammatic view of an atom, it kind of looks like this. It is a center, and then it has on its circumference around it is an imaginary path that is called the shell. The center is called the nucleus. All right, so electrons, they are revolving around the nucleus in these shells, and protons and electrons, they are located in the center called the nucleus. Now, a way of understanding or a way of representing an atom for someone that has not seen an atom like you or I, the scientists, they describe atom like this. So imagine the atom being the size of a football field. If the atom was the size of the football field, then the proton would be the size of the ball, the football that is present inside that stadium. So the nucleus is actually extremely small, and majority of the size of an atom consists of empty space. All right, so that is what is mentioned over here, that all the mass of atom is situated in its center, and majority of an atom is an empty space, right? Majority of an atom does not even have matter in it. It's just empty space with electrons revolving around it. Okay, and if you look at another thing, so the negative charges are revolving around the nucleus, whereas the positive charges are in the nucleus along with neutral subatomic particles. Therefore, we say that the nucleus of an atom is positively charged. The nucleus of an atom is positively charged. It has a positive charge on it. And that is why the electrons, they don't just leave even though the electrons are moving. So why don't they just move outwards? This is called tangential direction, meaning direction towards the tangent. If you're spinning something around, why doesn't it leave the circular path? So that is also explained in physics, but we can also understand it in chemistry as well. The electrons are being attracted towards the center by a positive charge, but because they're moving so fast, that is why they're moving at a specific distance. Okay, so the electrons are moving really, really fast. Therefore, they don't come towards the center, and the center's force is just enough to keep them in that path, does not allow them to run out of the shell, out of the orbit. Okay, so that force which attracts the electrons to the center of the nucleus is called the nuclear force. What is it called? It's the nuclear force. It is the force between the positive nucleus and negative electrons. An attraction which is generated because of positive and negative charges is called electrostatic forces of attraction. You have to remember this term, electrostatic forces of attraction. Okay, so the nuclear force is the electrostatic force of attraction between the positively charged nucleus and the negatively charged electrons revolving around it. I hope that makes sense. Okay, these are some terminologies that you have to take with you throughout your chemistry syllabus. We'll see a lot of these terminologies used in a chapter called chemical bonding as well. Okay, now we move on to some specific terminologies once more, which is atomic number, the first one. All right, now what is atomic number? Atomic number, which is also called the proton number, is a number that is described to us. It is present in the periodic table. If you check out the second video that I've uploaded of chapter 1, which talks about diffusion, in that I showed you the periodic table for the first time in the videos. I mean, you might have seen it unless you're living under a rock. You might have seen what a periodic table looks like. It's not something extremely beautiful, but it is something that helps you out a lot. The atomic number in the periodic table, I'll show the periodic table to you again. The atomic number in the periodic table is this number that is present above all the elements. Now, in some periodic tables like Edexcel IGCSE, these numbers are swapped. So the atomic number can be at the bottom as well. It does not matter. What you can try and remember is that the smaller number is the atomic number and the larger number is the atomic mass. If that is too hard to remember, or if you have a goldfish memory, unfortunately, then just because of you guys, the Cambridge education system, they also provide a key because they're humans and they have humanity. So they provide a key, and the key contains specific information about every cell. This is called a cell, by the way. In computer, you study that every intersection of row and column makes cells. So this is a cell, or this is a compartment, let's call it. It has four things, two numbers and two things. One is a symbol, one is a name. The other two are mentioned over here, so just use that. Okay, for IGCSE and O levels, I know for a fact that the above value is the atomic number and the lower value is always the atomic mass. You can try and remember that if you can. Once again, if you can't, it's okay. So this atomic number is also called the proton number. We're talking about the atomic number right now. Okay, so let's move back to the topic. Okay, so atomic number is the proton number, and what does this tell us? The atomic number tells us the number of protons present in the nucleus of an element or atom. Okay, so it tells the number of protons present in an atom of an element, specifically where in the nucleus of an atom. One more thing you have to understand about the structure of atom is that the nucleus and the neutron and the proton, they are stationary subatomic particles, whereas electrons are mobile subatomic particles, meaning electrons can move but protons and neutrons stay in the center. Okay, um, so it is the proton number, or the atomic number is the number of protons present in the atom of an element. Atomic number of each element is a known value provided in the periodic table. We've just discussed that it is always given in the periodic table. You don't have to remember it as either. But just like in my previous video, I have explained to you guys that you have to try and remember or be familiar with the periodic table before exam, so that it saves you time. Okay. Uh, Atomic number is also said to be the identity of an element. Now, what does that mean, that it is the identity of an element? Just like you and I, we have passports, we have identification cards. Our names can be similar to one another. Like, for example, my name is Muhammad Usman, and I know other people that's name is also Muhammad Usman. All right, and the father name can also be the same, but what is always different is the identity number. All right, the passport number. So we are identified by a set of numbers. Similarly, elements are also identified by a set of numbers. No element that was ever discovered knew its name when it was discovered. Like, for example, we did not just discover magnesium and ask what's your name, and it said my name is magnesium. So it didn't do that. Okay, so we did not know their names, we gave them their names, right? And on what basis do we give atoms their names? On the basis of the protons. All right, so protons are the identity of an element. An element which has 12 protons, or an atom which has 12 protons, is magnesium. All right, it does not matter about anything else, it is going to be called magnesium. Now, how many electrons it has, how many neutrons it has, that is up for discussion. But if it has 12 protons, then it is magnesium. If an element has 6 protons, then that is carbon. Okay, so number of protons, they tell the name of an element. So we discover, or scientists, they go, they take samples from earth or from outer space if they want, and then they look at those atoms and they search how many protons they have. Once they know the protons, then they name it. Okay, so if the number of protons happen to change, then the element also changes. That is what I'm trying to explain to you. The most important thing is, for example, if you had a way of pushing a proton into the nucleus of an atom, or taking the proton out of the nucleus of an atom, then that element would have a change of name. For example, if I talk about magnesium, it has 12 protons. If I happen to be able to remove a proton from the nucleus of magnesium, making it have 11 protons, now that magnesium, the same magnesium, it will no longer be called magnesium, but instead it will be called sodium. Okay, I hope that makes sense. Because a proton decreases, so now it has 11 protons, and an element or an atom with 11 protons is no longer magnesium, it is sodium. You have to understand that concept. Okay, I hope that makes sense. For example, an atom having 8 protons will be an atom of oxygen, always, because in the periodic table we can see that oxygen has 8 protons. All atoms have equal number of protons and electrons. That is the next thing. An atom, when we use the word atom, it must have equal protons and electrons. Okay, if it does not have equal protons and electrons, then it is not called an atom. All right, this is, then okay, I will give you the name of what it is called. Then an atom that does not contain equal number of protons and electrons, because protons can't change, so that means electrons have decreased or increased, then that element or that atom would now be called an ion, 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 all right, ion. And that atom would have a charge on it, either a positive or a negative charge. But because atoms have equal number of protons and electrons, that is why atoms are electrically neutral. Atoms carry no overall charge. Why? Let's take the example of oxygen. If it is an atom, then it has 8 protons, meaning 8 positive charges, and similarly, it would have 8 electrons, meaning 8 negative charges, giving it an overall whopping 0 charge, right? So atoms, when they have equal number of protons and electrons, they carry no charge because all the positive charge is cancelled out by all the negative charge. That is what you have to understand as well. Okay, so all atoms are electrically neutral, they carry no overall charge. Now we talk about the atomic mass. What about the atomic mass? Atomic number is complete. Now we move to the next topic, which is atomic mass. In atomic mass, we study the definition of atomic mass and what it is called and how it is figured out. So atomic mass is also called the mass number or the nucleon number. In O levels past papers, they really like to use the word nucleon number instead of the atomic mass, thinking that you guys are idiots, unfortunately, and forget. I'm not. I'm not. I did not say that. Okay. They think that you would forget nucleon number. The word nucleon number is so difficult. Unfortunately, it's not difficult, or fortunately for you guys, it's not difficult. You can just remember its nucleon number arising from the word nucleus. Okay, so nucleon number is also the atomic mass. Okay, what is the atomic mass? Now, for that, you have to use your concept. I just explained to you guys that 3 subatomic particles, out of which 2 have mass and 1 doesn't. So, atomic mass would basically be the total mass of protons and neutrons present in an atom of an element. Now, it makes it easy for us. Chemistry makes it easy for us by having the mass of proton and neutron as 1. So if something has 3 protons, then it has 3 atomic mass unit worth of mass just by protons, and 2 neutrons, then 2 atomic mass unit worth of neutrons. So in total, if the nucleus contains 3 proton and 2 neutrons, then it has 5 atomic mass unit as its relative mass. I hope that makes sense. Nothing too difficult about it as well. So atomic mass is the mass of protons and neutrons combined. Okay, so atomic mass, it is found out by the formula number of proton and neutron. Now if you recall the periodic table that I showed you, in the periodic table the atomic mass is always provided and the number of protons is always provided. So that means they are not going to go ahead and ask you give the atomic mass of calcium. They won't ask you give the atomic mass of potassium. They would instead ask you the number of neutrons, because the number of neutrons are not directly given. All you have to do to calculate the number of neutrons is rearrange this equation. Rearrange this equation means to shift things from one side of the equal to sign to the other side to make whatever is asked the subject. So if number of neutrons is asked, you have to rearrange the equation to make number of neutrons the subject. For that, you will shift number of protons towards the atomic mass side and subtract it, because over here it is being added. So number of neutrons are found out by subtracting the atomic mass by the atomic number. All right, so atomic mass minus the atomic number gives us number of neutrons. Okay, number of neutrons are what are usually asked, or sometimes they don't give you the name of the element, therefore you wouldn't know its mass. They give you like element Y has 26 protons and 30 neutrons, what would be its mass? So element Y would have a mass of 56 because 26 plus 30 is 56. But if they say iron, what is how many neutrons are there in iron, then you know that iron has 56 mass and 26 protons. So you subtract 56 from 26 and you would get 30 neutrons. Okay, so you have to use your mind over there. Okay, if they're asking about number of neutrons, then subtract the mass and atomic number, you would know the element and you would just have to look at it from the periodic table. If they have not given you the name of the element or the atomic number of the element, then they're most likely not going to be asking you for number of neutrons, then they're going to be asking you of not the atomic number, even the atomic mass of the substance. They could even ask you the atomic number. In that case as well, just Try and rearrange it. It's not that difficult. Okay. An example question states, calculate the number of neutrons present in the nucleus of an atom of potassium. So we have to calculate the number of neutrons in potassium. So from the periodic table, we check out that potassium has the atomic number of 19 and atomic mass of 39. A very easy question. You would just subtract 39 from 19 and you would get number of neutrons as 20. Okay, so potassium has 20 neutrons in it. I hope that makes sense. All right. And with that, the terminology atomic mass is also completed. So we know now both the atomic number and the atomic mass and their descriptions and what they're used for and their significance in the periodic table. I hope you guys are understanding. If you don't understand a question or if you have a question, don't understand a concept, please drop down a comment and ask over there. I will make sure that I reply. Okay. Next topic we have is the isotopes. Isotopes come from two words, iso and topes. Topes means place in some language. I think it's Latin. I'm not too sure. I'm not very good with languages. I do know, however, iso means same. You hear the word iso a lot of places, like isothermal as well. It is a term. All right. Isomer is also a term. All right. Isotonic is also a term. Isotonic is most commonly heard in biology, isothermal most commonly heard in physics, isomer heard in chemistry, just like isotopes. All right. So in the future, you will also hear about isomers. For now, we're going to talk about isotopes. Now, what do we mean by topes being same place? Well, if you want to understand it, I'll explain. But it's not something that you have to explain to the examiner. What you have to explain to the examiner is the absolute definition of isotopes. There are two. Any one of them is correct. But topes meaning place is because isotopes, if two things are isotopes of one another, then that means that they exist in the same place on the periodic table. Okay. Anyhow, the definition of isotopes is that isotopes are atoms having same atomic number but different atomic mass. All right. Isotopes, they're atoms having same atomic number but different atomic mass. That is the definition. Same atomic number, different atomic mass. Two keywords, either of which if you don't write, you might lose the mark. Okay. Or you can write the answer in a different way. Isotopes are atoms having same number of protons but different number of neutrons. Now remember, I told you that number of protons, if they are same, then the atoms are of the same element. So you can also use the word element in this answer, like isotopes are atoms of same element having same number of protons but different number of neutrons. Okay. You can say that as well, but it doesn't really matter. You can say it either ways. Both are correct. Now we talk further. So isotopes, this definition, you have to memorize it. It is asked just like this in the exam. Okay. Now, since isotopes have same number of protons, they also contain same number of electrons. We studied that if isotopes are atoms and they have not lost or gained electrons, they have not decreased or increased in electrons, then they must have the same number of electrons as protons. And if isotopes have same number of electrons and protons, then that means they are also electrically neutral. Now, another thing that also means is, and something that I'm going to bestow upon you guys, there's a good word, I also used it. I'm going to tell you guys that chemical properties of all elements, and chemical properties mean chemical reactions of elements, are governed by the number of electrons or the electronic arrangement. Any of those two words are good enough for you guys at this level. All right. So chemical properties, they depend upon the number of electrons, whereas the physical properties depend upon the mass of elements. Okay. Other than mass, they also depend upon other factors as well. But for a very basic level, we can understand that atomic mass contributes to the properties and the electrons contribute to chemical properties. All right. Keeping that in mind, we understand that isotopes, they have same number of electrons. Therefore, we can therefore say, because isotopes have the same number of electrons, they must have the same electronic arrangements, and therefore they must have the same chemical properties. All right. So in exams, for a 2-mark question, they ask you, explain why isotopes of same element have same chemical properties but different physical properties. So you have to answer like this: isotopes of an element have same chemical property because they contain same number of electrons but different physical properties because of their different masses. We studied that isotopes have different masses, so they can have differences in their physical properties, like their melting point, boiling point, like their density, etc. but they can't have difference in their chemical property. They would have the same kind of chemical reactions. Okay, now in this table I have given you the most famous example of an isotope, which is isotope of chlorine. Chlorine exists as two isotopes, isotope 35 and isotope 37. 35 meaning it has a mass of 35 and 37 meaning it has a mass of 37. Now we both know, both meaning me and camera, know that there are 17 protons in chlorine. How do we know that? By looking at the periodic table, of course. But because there's 17 proton, the 35 mass chlorine must have 18 neutrons to make 35, and 37 mass chlorine must have 20 neutrons to make 37 mass, right? However, they must also contain the same number of electrons if they are not charged. So chlorine, they have 17 proton and 17 electrons, but 18 neutrons or 20 neutrons. Okay, now in the last column is written as the percentage abundance. If I have to explain what percentage abundance is basically the amount of one type of isotope of the element present as a ratio or as a percentage of the total atoms that are present in the sample. So for example, if I took 100 molecules or 100 atoms of chlorine, if I took 100 atoms of chlorine and I analyzed it, I would find out that 75% of those atoms are having a mass of 35 and 25% of those atoms are having a mass of 37. I hope that makes sense. So that is chlorine 35 and chlorine 37. Now with this percentage abundance, a lot of important things can be done. All right, and what are those important things? For a start, with this abundance we can figure out which chlorine is going to be present or is going to have a higher chance of being present. The other thing that we can also figure out over here, or we can think about, is that because chlorine has two masses and because a lot of isotopes might have two masses, so some problems might arise. And what could those problems be? The first problem that arises that you should think about is, well, in the periodic table only one mass is written. So why is there only one mass written when there are two types of chlorines? Well, if they wrote two types of masses of chlorine, then they would be in a lot of trouble. The periodic table would look a lot more tricky than it looks currently. So that is why they don't write that. Instead, in the periodic table, they write the average atomic masses. All right, and at your level, only the average atomic mass of chlorine is written in the periodic table as 35.5. Other than that, no atomic mass is written as an average, but instead as whole numbers. All right. So these are rounded off numbers that might not be like this. In A levels, a lot of these numbers, they are written as decimals because numerous number of elements in this world exist as isotopes and their atomic mass is written as an average. Now it is your responsibility at this level, at O levels or IGCSE, to know the average atomic mass formula, how to calculate the average atomic mass if I know the percentage abundance and I know the isotopic mass. Okay, so you only need to know two things, the isotopic mass and the percentage abundance. If you know those two things, you can apply a formula to calculate the average atomic mass, which is calculating average atomic mass, the isotopic mass, which is the multiplied by the percentage abundance divided by 100. The formula of average atomic mass is summation. This symbol means summation. Isotopic mass multiplied by percentage abundance divided by 100. Now this is also once again a little bit of mathematics. So you need to know a little bit of mathematics. This symbol is seen in the chapter of mathematics called statistics, I believe. Summation basically means however many times we make this bracket, we add those brackets together in the end. Okay, and why would we need to make these brackets multiple times? Because there are multiple isotopic masses and each isotopic mass has a different abundance. So for example, if the question is calculate the average atomic mass of chlorine from the data provided above, then using this data we should be able to calculate the average atomic mass, and I will write it down over here how to do it. So the formula was AR is equals to summation percentage abundance. We can write abundance first and isotopic mass because 2 times 3 is equals to 3 times 2. That is also another rule of multiplication, that you can multiply things front or back, it means the same thing. Okay, so percentage abundance multiplied by isotopic mass, let's call it IR for making it fast. Okay, so divide by 100. What do? You make the bracket appear twice now. Why do the bracket appear twice? Because there are two types of isotopes, right? 135, 137. So you will write over here the first bracket 35 mass, or because I wrote percentage abundance first, so I will write 75 times 35, and then I will put the symbol plus because of this summation sign. Okay, 75 times 35, and then I'm going to add in it the second bracket, which is 25 times the mass of the second chlorine, which is 37. Divide this by 100. I don't happen to have a calculator right now, but I know the answer would be 3550 when you solve the upper two brackets and add them together, divide by 100. When you divide 3550 by 100, you would get 35.5, and that is why the average atomic mass of chlorine is 35.5. I hope that makes sense. If you have any questions related to the average isotopic mass, you can ask in the comment section as well. Okay, after this we move to the next topic, which is the electronic arrangement. In this we study about how electrons are arranged in shells. There is a specific pattern by which electrons are arranged in shells, and that pattern we have to follow. Okay, the electronic arrangement basically explains how electrons are going to be placed in shell. Every shell has a certain capacity. Okay, that capacity cannot be bypassed, meaning it cannot be increased. So only those number of electrons can exist in that shell, and then the next electrons have to go into the next shell. That's why atoms, they have more than one shell, they have multiple shells. It depends upon however many shells they need. Okay, so each shell has a maximum capacity to accommodate a specific number of electrons. The first shell, let's talk about the first shell. The first shell of an atom can only accommodate 2 electrons, meaning if any atom has more than 2 electrons, then the first shell takes 2 electrons, and then the next electrons go into the second shell. Okay, the first shell can only have up to 2 electrons, and it's called the duplet rule of shell filling. It's called the duplet rule of shell filling. You don't have to use this word anywhere in your whole syllabus. It's just good that you know that it's called a duplet. However, you should know that the first shell can only have 2 electrons. That you have to remember. Now the remaining shells, I've put them as the remaining shells because there is a specific pattern that we observe in the remaining shells, but this is not 100% accurate what I'm about to say. The remaining shells accommodate 8 electrons to become stable. Now I am politically correct. They have 8 electrons and then they become stable. Does that mean every other shell contains 8 electrons? No. The shells, they contain different number of electrons. The second shell can only contain up to 8 electrons. It cannot accommodate a ninth electron in it. But the third shell contain or accommodates 8 electrons, and then it is stable. But it can accommodate up to 18 electrons in reality. Okay, so is that important for us? We should know about it, but for us it is not as important. Okay, we should know that the second shell has a maximum capacity of 8, the third shell has a maximum capacity of 18, and the fourth shell has a maximum capacity of 32, but all of them become stable when they occupy 8 electrons or when they accommodate 8 electrons. All right, so for us, we can just stick to 8 electrons for the remaining shells and it will be correct for us. Okay, this is called octet rule of shell filling. Octet coming from the word octa, meaning 8. All right, now we talk about the electronic configuration, which is the important part. What is electronic configuration? Electronic configuration is a method of determining or explaining or depicting how electrons are arranged in an atom in a single line without drawing the whole electronic structure or the atomic structure. Okay, so it is a method to describe arrangement of electrons of an atom in a single line. All right, it consists of blanks separated by commas. So a single line which has a lot of dashes, and those dashes are separated by commas. The first dash signifies the first shell, the second blank second shell, third blank third shell, and so on and so forth. All right, each blank describes the number of electrons in each shell. The first blank from left describes the first shell of an atom, hence it could have a maximum value of 2, because we discussed that the first shell can't have more than 2 electrons. So the first shell can only have up to 2 electrons. Okay, the remaining blanks can have a value of 8 electrons for us. Okay, for us we are going to keep it to 8, All right, in exams, sometimes we will see the number 18, but we don't have to worry about it. They're not going to ask us about it. Okay. It is a rule that electrons always accommodate the lowest energy level first. That is also a rule. Electrons start filling shells which are closest to the nucleus, and then they go upwards. Okay, so unless the previous shell is not complete, electrons won't go into the next shell. They will go stay in the first shell. After the first shell is completely full, meaning after the 2 electrons are in the first shell, then they will go to the second shell, and 8 electrons will fill in the second shell before the next electron goes to the third shell. All right, so that is how electrons are filled into the shells. This means that electrons only accommodate a new shell once the previous one has been filled. So once the previous shell has been filled, once the previous shell has been completed, only then do new shells are filled. All right. So before that, new shells are not filled. Okay. I hope that makes sense. We talk about next example, and this is the last part of the electronic configuration, the example, and after learning the example we can figure out the way to writing the electronic configuration, and I'll let you know of other things as well. So the example for electronic configuration of calcium. All right, so we're going to take the electronic configuration of calcium for two reasons. Reason number one, it is the largest element whose electronic configuration can be asked by the examiner. um, So basically, no element bigger than calcium will be asked, or no element's electronic configuration bigger than calcium will be asked by the examiner for you to write in the exam. So that is the largest element whose electronic configuration you have to write. We should know that calcium, because from the periodic table we know it has 20 protons, so it must have 20 electrons, because we said that it has same number of protons and electrons, right? So its electronic configuration should be that 2 electrons come in its first shell, then 18 electrons are left, then 8 electrons come in its next shell, now 10 electrons are left. I'm just subtracting from 20, and then 8 more electrons come. Now only 2 electrons are left, and 2 electrons go into the last shell. I said that 18 electrons can come in the third shell, but first, after 8, the second shell gets 2 electrons, and then magic happens in the third shell. The next electrons are started to add in the third shell, but you don't have to know about it. Okay, what you have to know is up till calcium the electronic configuration goes 2882. This is the electronic configuration, a way of writing arrangement of electrons in a single line. All right, from this electronic configuration you can judge a few things. You can judge that calcium contains 4 shells. All right, first shell, second shell, third shell, fourth shell, and the outermost shell of calcium, which is also called the valence shell, contains 2 electrons, meaning calcium has 2 valence electrons. How many valence electrons calcium has? 2 valence electrons. All right, so that is what is mentioned down here. From the above electronic configuration we are also able to figure out that calcium has 4 shells around its nucleus, as there are 4 blanks in the electronic configuration. We can also see that calcium has 2 valence electrons. Valence electrons are electrons of the outer shell. For O levels or IGCSE students, electronic configuration only is required for up to first 20 elements, no more than that. So life is easy, life is good. The biggest one is 2882. The element right before calcium is potassium, which has 19 electrons, so it must have 2881. The element before potassium is argon, which has 18 electrons, so that electronic configuration must be 288, and so on and so forth. It is good practice if you write the electronic configuration of all the first 20 elements in your notebook for practice and figure it out. It's very simple. All right, and with that being said, this chapter has also been completed. I hope you guys understand. I hope there is no question. I hope everything is crystal clear. I'll end the video over here. Thanks so much, and subscribe. Bye bye.